Okay, resume recording. Hey, it's Coffee Compiler Club here today to talk about compilers and language runtimes and typing systems and jet lag and anything else to do with compiler implementations and how people, engineer things. You're being recorded. You'll be up on YouTube within a couple hours if I can remember how to do it with my jet lag brain. And no set agenda. Ask questions if you got them. And that's it. I have an opening question statement, something, because we were talking just about being unable, Levo dropped and wants to rejoin, being unable to detect a change after a massive refactoring. And this was Aaron's first bug was it failed to deploy. The second bug was, in fact, it made no change or random change. So brings me back. I'm 22, something like that. I'm trying to do something at Motorola with compilers. I'm doing an optimization that ought to do something, and it got a little better. And then I changed something that ought to have helped. It got a little worse, and changed something that got a little better. And it kind of, trying to figure out what's going on. And I didn't have statistics in my brain yet, so I didn't recognize random noise. But I was certain there was some kind of screw up going on that I couldn't nail down. So I got hardcore about this one because I had several of these come by now. And I started doing binary search on optimized binaries to see at the link step to break out things that have been optimized and not, and see who was giving me performance gains or losses. And this all gave me, more or less random numbers for a while. And then I got like, oh no, this is ridiculous. So I started reshuffling the link order, and I got different numbers. And then I got a little more hardcore about trying all kinds of combinations of like 50 object files to be linked, and got, plus or minus 10%, which is much bigger than the kind of thing that I was trying to optimize for. And then, had a long talk with the other much more senior compiler engineer guy there. And we decided there was something going on in the icache and the layout was mattering. So we profiled the hell out of a bunch of things and discovered, in fact, icache mattered. And what was going on was we had a four-way associative icache. And if you had four hot methods line up on the same icache line, or five, they shared and they kept mutually evicting each other. Meanwhile, all these cold lines were sprayed out all over the cache, and they weren't doing any good for living in cache, but no one was going to evict them because no hot code, there was no code running that was going to hit those cold lines. So we then profiled again and gathered our profile data and decided that we would break every function up into a hot, medium, and cold part, every single function. And then we made all the hot parts line up together and all the medium parts and all the cold parts. And this forced the hot parts to roll entirely through the icache, through the four-way associative, before you got into colder and colder and colder bits. And that was worth like 20%. It was like a big number, far exceeded everything else we were ever doing in the last year, and far made random noise out of all other choices we had been making. All other things we've been doing that is 2, 3, 4% were well below the random noise of, potluck on the icache layout. So that was my first hint that icache layout was a bigger difference than all these papers you'd read, the academic report of blah, 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 super optimization, this, that. We got 2, 3, 4, 5%. They're all noise. 90% of all the papers I've been reading out of grad school were noise. Fine. Okay, I'm done with my random war story.
So you would say the biggest wins are inlining, register coloring, and
icache layout.
icache layouts?
Stupidly. Yeah, and modern x86 is maybe a little better. They're 8-way associative. You have to get 9 or more pieces of hot code that mutually co-conflict, which maybe can still happen reasonably often. I'm fairly certain on the very larger code bases you get out of like Hotspot, where he generates, hundreds of megs to gigabytes of code, eventually into a giant ass, 100 million line program. There's probably some serious icache layout things you could do, and they would probably actually exceed many other things. And no allocation is another big one. It's very similar to no icache or icache layout. So I imagine a well-functioning escape analysis would also buy you a decent chunk. Loop ops are easy, and you just do them. And after all those are like done, like you have to do dead code, and you have to loop ops and common sub-expression. And then you're kind of like pushing yourself into a domain where inlining goes hand in hand with register allocation, because you over inline, or you should. Now you have a lot of code because you've inlined a ton. Now I think you need icache layout. And the stupid thing is all these things, like the first one hides the next one, so you beat it down as low as it reasonably can. And then the next one becomes pretty big numbers. There's another, 10, 20% line there, and you beat it down, the next one is another 10, 20%. So it's exponentially, growth in terms of performance. You have to do them in order, but then you keep getting bigger and bigger numbers out. I don't know.
So the solution was to have the hot functions lined up after each other?
Yeah. We actually split the hot functions into 3 parts because we didn't know who was mutually hot relative to each other. So we ended up with like the hot inner loops of each of the functions stacked one after another. And so, yeah, they would rotate through the icache, each taking their own line, and then the second hottest one would compete with the most hottest, or whatever. The 64K hottest would compete with the I guess it's 4-way associative on a 64K, a 16K icache back at that era. So divide by 4. After 4K of hot code, the next 4K plus 1 competed with the hottest code. That was the theory of how it was working, and it worked pretty well.
Just to clarify, so the solution was just having as much hot code together in one cache. It's not specifically about the order.
Yeah, the goal was to get, you're right, the goal was to get hot code to stay in your icache. And the problem was 4-way associative and 5 hot lines sharing the same 4-way associative. Always one of your hot lines got kicked out of your icache. And then on the chips of that era, that meant you couldn't even begin prefetching or running anything until you got the line back in the icache.
Yeah, it sounds rough.
Modern x86 suffers from the same problem pretty heavily all the time. They pipeline better and shit, but if you keep evicting your icache, you'll he can't do wide issue on nothing. You got to have it pulled in first. So
if the body of your loop is big enough, could it actually be faster to run through the entire data set twice than have a loop that's too big?
Maybe. If your decache,
that's very counterintuitive to me. My answer has always been never run through the loop twice.
Yeah, right. So suppose your data set is small enough to fit in your decache, your L1, but your loop construct body is all hot and big enough that it does not fit in L1. Is this going to do? No. Your loop, you just you have to. Oh, and you wanted to fork your loop, clone your loop body, not fork, split your loop, unfuse the loop, and do 1 pass and then a second pass. Yeah, maybe. That's a weird situation to get into, but you could totally imagine doing it. Usually your data sets far exceed your caches. And because of that, you only want to go through once.
Right, but so let's say my data set is a bunch of like delta encoded integers. So there's a whole bunch that fits in one icache.
Decache.
In one L1 cache.
Yeah, L1 cache. Yeah, right.
But every time I go through the loop, I have to do everything in the icache and then take a cache miss and then do the little bit of loop that doesn't fit.
The x86 can't prefetch the icache fast.
Whereas even if I have a big amount of data, if I'm running through it twice, I process a lot of data.
Yeah.
And then I have a cache miss, and then I process a lot of data and have a cache miss, and then I process it. So like, even if I assume the data is big enough that I have to stream it through, it still might be faster to stream the entire data set through the CPU twice.
If your icache is endlessly missing.
To deal with an icache miss on every iteration of the loop.
Yeah, I don't know. I think you could arrange for that, but I think you'd have to be pretty specialized. Like if you're just flowing through a big unrolled loop body, the x86 will prefetch the icache and he probably keeps up. If you have irregular control and complicated, so you're doing some bizarre, machine learning involving, whatever neural nets, you have a tiny piece of neural net that you're updating continuously, but your icache is too complicated and he can't predict. Then
you would need a very simple data with a really complicated loop, but it's actually possible.
Yeah. And he's missing his predictions constantly. Then maybe you simplify.
That hurts my brain. I would not have thought that would happen.
Exactly. Yes, I think it is possible. It's not a common thing that I've seen, but maybe.
I had a relevant question, but I think only a few of us use this perf, and Matt's not here. So maybe I'll save it for next week. But I did an experiment with the cache, and perf numbers weren't giving me what I thought I would see. So that was a little strange.
Okay, you said it. Now you have to ask the question anyhow, instead of saving it for
Okay.
next week.
So yeah, I don't think anyone can answer this, but I wanted to get Perf to show me numbers so it's easier to figure out what part of my code is having misses without specifically doing the cache miss event. So the experiments was I had one huge array, two functions that were almost exactly the same. One of the functions would just iterate through the same like block like multiple times. So that would be like my control, just to see how fast it would take if everything's in cache. The other function was nearly exactly the same, just different literals. That actually did random access. And Perf was saying that the compare on the if was actually the slow part rather than the moving to or from memory,
Yeah,
which was
you're
really strange.
on an x86, right?
Yeah.
Yeah, he does out of order. So you do a load, it misses in your cache. So he continues execution until he has to have the load value to do something. And then you take the perf hit on the instruction that uses the load value, not on the load. And in fact, usually on a compare, he'll just assume that one will show up after a while. And then you hit a jump, which he wants to predict on. And he's out of predictions because he's 3 layers or 4 layers deep of mispredicts already waiting for icache. So a load 3 icache misses ago went through a compare and a jump that he predicted, and then another load, which is totally predictable, predicting or whatever, missing, and a compare which predicts another jump, and he gets too many layers deep and he says, I can't issue anymore. So I'm going to stall now after I'm 5 layers deep and blame the last guy in the chain as to why I'm stalling.
Okay, yeah, I didn't realize that you can get like 5 layers deep into prediction and then stall.
It varies by x86 and by sort of a very exact sets of instructions you're executing through. But you can imagine one pretty easily. And I know he's gone to 2 or I think 3. And I can also imagine him going to until my reorder buffer runs out, which could be 100 divided by 4 or 5 ops per your whatever your loop body's doing. So I'm doing 50 down the road or 20 down the road, like a long freaking way. And then the first mispredict, he blows all that work away and goes back to square one and tries again.
Yeah, no, that makes sense. I wonder if I can find my Zats code, but I think that actually solves the mystery.
Yeah, I mean, I've watched x86 profiles, and in the beginning, you missed a load, you blame the load.
Why
and then
do
later in
want
life, you blame the user of the load. And
why
then
do you want to profile a random access?
he wants to profile random access. It's actually,
Right.
you know, it's useful to get to understand what the hardware's doing.
The rules are set decades ago. If you make your data predictable, then you're fast. If you make your data random, hard to guess, then
But exactly where the blame goes. See, the learning here is you're blaming the user of the load, not the load. So when you next come to a profile and you're confused about what the performance issue is, because the instruction that's taking the blame looks innocuous, you know now to look backwards for the nearby memory op that may have missed that you're now, you know, and then actually the access pattern that not the thing you choked on, but the access pattern leading up to the thing you choked on.
Yeah, so my curiosity was when the hardware counters count things, what is exactly pointing to? So that was the confusing part to me.
Yeah, and those have varied over the years by a lot. So
yeah, I thought so. Yeah.
Yeah. Back when I was doing profiles with just like interrupts, the answer was he'd wide issue. You never took an interrupt in the middle of a wide issue. But if somebody halted for a stall condition, then he'd take an interrupt. So you got the interrupt on the instruction you were stalled at, which was not the load that missed, but the consumer of the load that he didn't want to go past. And then hardware perf counters got more clever and they did more things with them. And I haven't stared hard at the x86 perf counters in the last few generations. So don't know at that point.
So we have a totally different topic if we're at the end of
Yeah.
that.
Yeah.
So I grew up writing a lot of Python code and have recently started writing.
All right.
Implementing an interface.
Wait, somebody,
Did I
somebody
just disappear?
Aaron, yeah. Somebody just disappeared. For me, you disappeared and other people seem to have been moving still.
Okay, so in Python, you use strings to implement an interface. If I'm making an iter, I just need a class that has under, next, under. And as long as it's got a next function on it that keeps returning things and eventually throws stop iteration, it's an iterator.
Gotcha.
In Rust, things tend to say, oh, I would like to implement this interface. I need to import from the package the interface that I would like to implement, and then say, I'm implementing this interface, and now make a function with that name so that I can have funct has a toString in it, and display has a toString in it, and prettyprint has a toString in it. And all of these functions are called toString, but you can tell them apart because I told you which interface's toString I'm implementing right now. And I was curious what people thought about this, like, you implement an interface simply because you have a function that has that name, which runs the risk that you could have this collision of I'm trying to implement two interfaces and they both want the same string and now I'm screwed, versus
The same function.
I'm in the same function name.
Yeah, same function name.
If
yeah.
I have funct that wants a toString and I have prettyprint that wants a toString,
Yeah.
what should my toString function do?
You should implement toString, and that satisfies both interfaces.
And like, on the one hand, I totally get why the Rust community wants to say, you have to import the interface so that it's explicit, so that we don't have this land grab for the good names of functions. And Python solved this by saying, okay, well, there's some special functions because next is not actually the function you implement. It's underscore next underscore,
Right.
because underscore belongs to Python.
Right.
You don't get to rank those.
Okay, but what's the problem with toString? And what's the interface says I need toString. A lot of interfaces say toString.
Is that the interface, if the interface for funct uses toString,
Yeah.
now the interface for prettyprint needs to use display, and the interface for a debug string needs to use repr. And you end up with this land grab of things have to come up with different names.
So it's really simple, Cliff. In C, functions are pointers. In Python, functions are passing a string to something, which then does a laddered if statement on it and decides what to do. So it's like comparing C and Smalltalk, basically.
I'm not.
So Python is like Smalltalk, but without the design.
I'm not. That's maybe not answering my question. If some interface says I want a toString and he produces a signature, and a second interface comes along and says I want a toString, if he has the same signature, you only implement it once, it satisfies both. If he has a different signature,
that's really cute that you think it has signatures. Yeah, it passes a string that says toString, the end.
Oh, I see. Ah, geez. Well, it's not typed because it's Python. Of course, it's not typed.
Well, it's typed. Every type's a string, but it's typed.
I mean, you get a type failure at runtime. It is not statically typed.
Right. If you try to print a thing that does not implement under, stir, under,
right,
then you will get a attribute error. This thing can't turn itself into a string. I can't print it.
Right. Okay, but if somebody implements string and they're expecting to take a widget and produce a string back, and somebody else wants to call it toString, but they're taking a foobar instead of a widget, then you get the wrong one, or you get an implementation that takes widgets and the foobar guy blows up because somebody, well, you have two different toStrings that you could, in a statically typed language, tell apart by the incoming signature, and in Python, you cannot tell apart.
So Python has a cultural problem of you need to know that stir means produce a string that is a reasonable string representation for things like calling print. That calling repr is produce a debug string that shows you all of the fields that are there and is often very much more verbose and not the thing you want to show someone unless they're trying to debug something.
Right.
And that prettyprint is prettyprint.
Okay.
And
see.
culturally, they've decided here are these 3 strings and what they mean as function names.
Right.
But you have to agree that you're not all going to call the thing toString because you'll collide. Whereas in Rust, you don't have this problem because I can make a toString and you can make a toString and someone else can make a toString and have different cultural understandings of what those mean. Because if my object just has a toString function on it, I have not implemented your interface unless I explicitly say I am writing toString as a implementation of this interface, which is a symbol that I imported from a package.
Right. Yes.
So it disambiguates things. And I'm trying to decide what people think about that kind of name spacingness of
Okay, so
string function names for implementing.
I have another question that immediately comes after that one, which is, can I implement toString for each of the different interfaces? I'm implementing 5 interfaces. They all want toStrings. I have 5 toString implementations, 1 for each different interface. At the call site where I call toString, I disambiguate because I tell which interface I happen to be calling.
So you can certainly implement all 3. I don't remember in Rust how you disambiguate at a call time. If I need object.toString, but there's 3 of them, how I tell you which one to call.
Okay. I cast it to interface left or right. I mean, that's just like a fucking hidden extra argument to the toString. That's your interface, and that's your forced disambiguation.
Yeah, it's essentially a hidden argument that is a symbol to toString to help you disambiguate, as opposed to a just using the name of the function.
Right. I'm in the opinion that
It's like my understanding with AA is it's just the name of the function.
Yeah,
I implement an interface
tied.
as long as I implement all the strings.
Yeah, right.
Yes, and I take the right arguments and return the right argument.
Yeah,
Right,
right.
it's a signature, not a name,
Yes, it's
Yeah.
signature, not a name. That's
which is
right.
why I was cleverly correcting Cliff earlier when he assumed that Python used signatures.
Yes, I was assuming. I haven't done that level of gaudy detail in Python to notice that it didn't. He takes arguments with their types, this and that, but he doesn't have any signatures.
Yeah, Python's really
Yeah.
unique. Well, not unique, but Python is actually quite strongly typed.
Yeah.
But it's not statically typed.
It is not static.
So it's
Yeah, right.
dynamically strongly typed, which can be quite nice and also can be quite infuriating.
Well, I've done my Python salt mines and understand where it falls over.
Yeah, and there's some fun demos if you like
Oh, yeah.
overload to bool, but instead return the empty list, which is falsy, but not actually false.
Yes. Well, all languages have their obfuscated, call sequence, whatever. I am not yet stared hard in ecstasy for the worst case scenario, but I'm certain it's there.
I haven't implemented it yet, but for Bolden, I was planning to. You have to explicitly inherit the interface, and if there's a collision, there would be a way to say which one you're implementing. But yeah, it didn't seem to be great as in readability because everyone's going to want the same names, and I'm pretty sure that everyone's just going to like put interface : and then the name, and there's no way to win with that one, I think.
Well,
So
I think
always
static,
So in
it's-
Bolin, you have to import the symbol from the package in order to implement its interface.
Yeah, that's what I prefer. Yeah,
okay.
just
Okay.
because this is meant for complex projects where people are going to be stepping on top of each other. So yeah,
But it means you cannot implement the interface of someone who you do not know exists.
correct.
Yeah. And I'm in the zone of, I think I can handle both straightforwardly. So I'm going to do both. But one was called nominative and one's just static typing.
So in AA, how would I implement an interface using a symbol that I imported rather than just happening to have the
Yeah.
same signature?
You put the name on the, you have to annotate. You have to put type annotation. There's no inferencing of that thing. You just put type annotation. I implement the, I don't know, foo interface. So you put a : foo somewhere in your type declaration. My bar implements foo and specifically, and then whenever I need it, if I need a foo, I can declare a function that takes a foo, an interface foo, an iface, and I have to have a thing called iface as an interface part. That's the that's the behavior of the implementation is you just throw a hidden extra argument on the type that has to now match.
So if I want to implement iFace toString and uFace toString on the same object.
The object implements iFace, it implements uFace, and it implements toString. And then the uFace toString and the iFace toString have to be compatible. I'm sorry. If they are identical, the one implementation covers them both. If they have different signatures, I tell them apart by signature.
But what if they have the same signature but different behaviors? One of them is print and one of them is pretty print.
You only get one implementation now. So you have to pick which one you're going to implement. That's my current theory, what I'm going to do there. One implementation covers them both because signatures are the same.
Do you have any ability to locally rename things so that I could, when I import one of those, I can give it a different name locally and then implement it with that different name, something like that?
Yeah. If you, but it's just the obvious sort of renaming thing. So if I say I implement some iFace and I implement some uFace and they both have two strings, the iFaces and the uFaces will all call the same toString and you only get the one implementation. If I want to call,
I couldn't change like uFaces toString to u2string or something, and then
uFaces
and then
names are out of your control. That was defined by uFace.
Mhm.
So you can, if you can tell them apart some other way, you can wrap them in a name that gives you a different name. Go like if one of them's got a different signature than the other, then they're told apart by signature, and you can wrap them if you care, but that didn't matter because they're already tollable apart by signature. But if one is expected to do a normal toString and one is expected to do a debug toString, and you call them all toString and they have no signature changes, you only get one implementation. That's my current.
You have to disambiguate them by, in the caller's context, what type does it think I am? If the caller thinks I'm an iFace or the caller thinks I'm a uFace, to do different things.
No, because the typing system knows that you're in the you may be in the iFace context. I don't know if I can tell you're in the iFace context. I know that you match the iFace signature here and you're calling toString, and I probably also know exactly what kind of type you are.
So there is a potential pain point in AA of, I have a particular object that I would like to pass through two different libraries which want interfaces implemented, and they happen to have picked the same function name, the same function signature.
And I want two different,
but they mean different things by it.
And they want different things. But yeah, right, exactly. And I'm thinking through, and it's kind of an odd situation, and I don't. This is like a consistency, coherency question now, and I'm thinking life is a lot simpler if you all agree on the same name. You're going to get the same implementation, and that's what it is.
And that's why I force you to inherit.
Well,
if you have a lot of dependencies, something's going to collide.
So it's
so my instinct is the AA thing is the one I want, having used Python and having used Rust.
Yes.
But this corner case feels like it could actually cause a lot of pain to somebody.
I think
when suddenly you can't use two different libraries at the same time.
The thing is that you just need some sort of wrapper or something, and then you can get around it fairly straightforward.
You can certainly do it. Yeah, you can certainly do a delegate thing. This is like, I think you just said it, Aaron. This is a corner case, and I'm willing to let the corner case be, cornered.
Okay, so maybe the wrapper is the answer, is that if I want to call library U, I create a U wrapper around my thing. And when I want to call library me, I make a me wrapper around the thing.
Yeah. So you end up
and it just calls two different functions that are in the actual object. And
Right.
for all my code, it's got two different names. And it's only at the moment that I'm going through that library that I say, here's the thing I'm passing to this library. It's a very thin wrapper that just calls into my stuff and does the change and then comes back and then I unwrap it.
You just invented the delegate.
How well can AA do that? Like in AA, would I need to implement every method in my wrapper to forward on? Or like say I've got 50 methods in this object and I have one pair, like one name that has a conflict. So I need to make this delegate in this example. So do I need to implement 50 methods in the wrapper, or is there some way that I can sort of,
I'm trying to think if there's some cheap way that I could give you all the methods except what you override. I don't have one off the top of my head. I know I can do crap with eval that would do the job that sounds, and do it safely.
Like
And then
sort
it
of
sounds like,
macro-y type thing.
yeah, I'd have to hack. There'd be some evil hack, and then this could just be turned into some straightforward evil hack, and then it's not evil anymore. It's quasi quoting or whatever.
Yeah.
But I don't
you
have
just
one
make
off
it
the
a
top of my head.
library and then it's legit.
Yeah, first I want to finish sorting out my ints versus pointers questions, which I think I've figured out where I'm headed next with it. The magical trick of JCrete was that you get lots and lots of time to think about things and all the jet lag in the world to dream up stupid things that can't possibly work, or stare at your code and like your head keeps wandering off because you just no focus because it's 3 a.m. or something.
So is JCrete, were there talks?
Yeah. It's an unconference. So in the morning, we all get together and vote on what we want to talk about. And everyone proposes something, and then we vote on the proposals, and then the winners break off into groups. And if you don't like what's going on, you go to a different group or start your own. No one cares. It's all fine. And then after an hour, we hard break, come back and do it again.
Sounds fun.
It is. It's very relaxing in the sense that people keep voting what they want to go to, and only people present are voting up topics. So there's no weird topics that no one cares about because they don't get voted up by anybody. So you don't have to worry about missing them or not. And then
the thing about all this is that there's likely going to be 2 talks, 1 and 10 at the same time, and yeah.
We have the discussion about moving talks
happens.
around. If there's a bunch of people want to go to both, then there's a discussion about changing the schedule up, and one of them gets pushed out. It's fine. So yeah, if you
And
wanted to
you
go
can
to
also-
both, you could raise your hand and say, wait.
You can also get up in the middle of one and go to the other. It's
And
like
you
there's
could,
no-
you could decide that this talk didn't turn into what you thought it would be, and vote with your feet.
So it's an optimizing conference.
Yes. And then in the afternoons, we generally take or half the day, we generally take a excursion somewhere. So
Also, the barbecue is very nice.
yes,
Of course, Cliff likes his just-in-time conferences.
absolutely.
Who needs
the
ahead of time
just-in-time thing
compiling?
was just an accident of nature. It had nothing to do with what I liked or didn't like. It was just worked out. I fell into that one. Hey, Alexis.
Okay. So if you share the doc and look at the piece of code, is this roughly what you would do in AA that would wrap to solve this problem?
Hang on. Okay. Oh, you want to share the doc? Then Google Docs. Yes, I was going to have you share. I'll throw up Google Docs. Me wrap and you wrap a bunch of 2 strings, and you want to say
Right. Me assumes I have a function named toString. You assumes I have a function named toString.
yes.
They want different behavior.
Yes. Well, so you'd have an object that would have an instance of a U, and that's your delegate, and you call u.toString, and the me guy just calls his own toString. That's the use, right? Just the use guy, but the me object has a delegate of a U that he just calls into. Oh, you want to make a U wrap, which calls the U toString versus the me toString and goes back to the me object or whatever. The way to do the delegate here is that somebody has to be in, somebody has to be the outside, somebody has to be the inside. And you have an original object and you want to delegate to, well, you could subtype. Can you subtype? Oh, but they're interfaces. Oh, but it's AA, and that's not what counts.
Right, it's AA. So I'm creating a new object. I'm taking the thing that was, although I guess I actually, when I say ... here, I need to ... the thing. I don't know how to explode thing.
Well, that's what I've sort of come around to. So there's an original thing that wants to implement 2 interfaces. What I see you're writing here is I have 2 implementations based on 2 interfaces, but you didn't write the original thing that's busy implementing 2 interfaces. And the way the delegation works is the thing only implements one of the 2 interfaces, and he delegates to the other one. And the delegate just like throws everything back at the thing guy except toString. And that's the complicated thing. That's what Derek was trying to figure out. What's the callback rules on the delegate?
Or the Scala rule, maybe. A Scala rule
What
takes
we're talking, what I would do in AA here, given my current, I can be interfaces and I can be classes, and they're not really, the classes aren't
Scala,
terribly classy.
The Scala rules means if you inherit multiple interfaces that has the same method, the last implementing interface wins.
Okay, you're very quiet, Theodore,
Oh.
which is not normal.
Now?
Yeah, that's better.
Okay, so if in Scala 1, let's say, if you have a interface that multiple interfaces that implement the same method, the last guy wins. The last implementing interface wins.
Oh, you just put a rule on it that said
There's something called the linearization rules from left to right. The most right guys wins the race.
And when you say implements the interface carries basically a default implementation of some function.
Mm-hmm.
And someone says, I have a classy guy, he implements iface 1, iface 2, iface 3, all these ifaces 1, 2, 3, all implement toString. Iface 3's default toString wins.
Yeah.
In the land of Java, in addition, if the class implements a toString, it beats the interface's default implementation.
Mm-hmm.
So there's
we do it just the opposite, Theodore. So if you say implements I1, I2, I3, the first one wins. Because what happens is we build a list of the default implementations. So your first one wins as opposed to the last one.
You can equalize this to the most strong binding function. The first one is the most strong binding implementation, let's say.
Yeah.
The second one is weaker, and the third one, and so on.
It's one of the things where consistency beats decision.
Mm-hmm.
Yes, exactly.
Oh.
And
So,
it's.
But
yeah.
I think you can get around that.
So my thing has two distinct functions. And each wrapper is essentially forwarding one of them, but not the other.
So you want a me wrapper to have a thing internally as a field. And then if you call the me wrapper, he calls thing toString. And if you call anything else, you want to call the thing's other
Well, thing
function.
exists in this context. So does it need to, like, it is wrapping thing because I used thing to construct it.
Well, I'm missing where you me wrap uses thing as part of this.
I define toString to be the function toString that came from thing.
In me wrap, you're calling thing. Okay, you have to have a thing in context. So if you're using the externally provided thing, then your closure picked it up.
Yeah.
Yeah. Okay.
And then I've got some kind of explode notation that just says, oh, and everything else that was in thing.
Yes, and that was the part I was trying to make sure we were on the same page on.
That's like this is exporting.
Yeah, this is where Derek was saying, how do you do all the other fields? And that's your current hint on explosion thing, and I don't have an explosion syntax.
Well, it could be either that, or you could maybe
there, I am tuple unpacking all the fields of thing into this context.
Can you do
there's an explode syntax.
There you go.
Like, for instance, in JavaScript, I could just clone the object and then reassign one of the fields in it.
Yes, you could do that too.
Would that that could be done in AA?
Yeah. Yeah.
So that would be
for that to work in the way that you performance way you expect it, the field has to be mutable that you're overriding after you clone.
Yeah, so can you make a function like a function slot in an object mutable in AA?
Yes, it's just a field. It holds a function pointer. If it's immutable from the get-go, I'll move it off to a class and save you the storage in the object. If it's,
But this can't boil away to nothing because my functions are at two different offsets in my object. So the thing on the other side that's calling it, when I compile that thing,
okay, so
am I
wait,
going to get two versions of the target?
so the reading this code top to bottom and stopping where it gets to confusion here.
Oh, I guess that's fine because when I compile me, it just wants the offset into the object that's where me2string is, and you wants the offset into the object where you2string is.
Yes.
So maybe it can compile away to nothing.
Yes. But it has to have the thing. So if the thing, if there's only one instance of thing, how you wrote it here, there's only one instance of thing. It's exactly a static singleton thing. Thing dot me2string turns into a function pointer to some body of code and the thing itself, because I always include this pointer with the function pointer with fat function pointers, which I know how to boil away to a single pointer. So you get a single pointer, it's the thing, and it's a function pointer to me2string in the me wrap. So it does what you expect. And then the U wrap does the same game. As soon as I have multiple variant, but having done the assignment here, no, the assignment should go. That should still work. No, I claim this should work. Just boil away to nothing as you expect. I think it should.
Okay.
I'd have to
in
go.
that case, I think I'm fine with just using strings, using interfaces.
But like here's another case where I can boil it away to something sort of straightforwardly. It's, it moves into the class object here. Let's see here. My thing. I'm going to make geez, go away, Google. Okay, I'm going to make a type.
Wait, you type the @ symbol sometimes when you don't mean to mention other Google accounts?
I'm sorry, say what?
You type the @ symbol sometimes when you don't mean to mention other Google accounts?
Yeah, exactly. It's true. So I have some function is equal to some random number generator, question mark, and a function that returned to 5, and another function which returned to 7. Okay, so instances of my thing will have always one function. It will only ever return. So T0 is a my thing, and T1 is a my thing. This is like saying new my thing. I said class my thing in Java, except that the function is picked to be one of two different functions, a return 5 or return 7. So, T0.func always returns 5 or 7 according to whatever random came out. And so does T1.func. But the point is that the function variable in the my thing type had some computation to pick which the function was. It doesn't have to be a function body directly. You can have a computation that produces a function. And since it's finally assigned, you got a function in the class. It came about from a computation that produced a function, but that's fine. And kind of what you're doing above with instances instead of types is I'm doing a computation that produced a function, and I'm storing it in an object. Now, if you were to make the me wraps and the u wraps to be a class instead of an instance, then the stored value would go into the class and your instances would not contain any storage space for it.
Is it, so just sort of out of curiosity, is it possible to mutate an underlying class and then implicitly change all of its instances?
Yeah, I could arrange for that to happen. I could arrange for you to arrange for it to happen. That's not any default behavior.
Yeah.
But yeah, classes right now don't take mutable fields.
I see. So you could change it so that they did, but right now they don't do that.
And right. And the point of the class is I infer for you on your behalf what a class means. It's all like prototype style classes, if you will. The class is just all the all the immutable fields that are immutable in every instance. So in my thing case, I have a func, which is an immutable field because I signed it with the plain equals, but I might have a value object, which if I don't put any assignment into, it's a mutable field and it starts with 0 and you put something in it. Or I can say, hey, it's immutably, it's mutably assigned to some string. It goes in the instance object because it'll change in the future, and every instance will have a different value. Could have a different value for value. Might be ABC, might be 17. I don't know what it's going to be.
Right. Yeah. So everything that's immutable becomes effectively static and
moves into the class. Yeah.
Moves into the class, and then everything mutable is in the instance.
Yes. And then if you want to make an instance have a mutable field after you've mutated it for a while, that's the final field assignment that just says, okay, now it's immutable. So I have a cast field to immutable, if you will.
Right. Is it possible? I'm just sort of thinking through different scenarios here. It's not really relevant to anything, but is it possible to expose the machinery so that I can have an instance that is in virtually every way like a class itself?
I think I cannot avoid it. It not only should be possible, I think it's unavoidable.
Uh-huh.
So this is,
meta programming type stuff.
This is like a Python-ish, I'm faking classes for you, or JavaScript-ish, I'm faking classes for you, and I'll make it convenient, easy, but you can fake your own. And if you look at my convenient, easy thing, it'll be blatantly, obviously, a thin wrapper, syntactic sugar.
Uh-huh. Yeah, okay.
So that's my current theory how that's going to work. Obviously, I don't have an implementation, so I'm just blowing smoke right now, but who knows?
Right. But that means that if I wanted to do kind of stupid things like have, what seemed like mutable static methods, I could just create my own class implementation that allowed me to do that at sort of the user level, then instantiate my classes instead of normal classes, and then I can shoot myself as hard as I want in the foot.
Right, exactly. My current theory on that one is you'll fail out on the performance optimization of it's a static final field, I can inline it. And so you won't get a function call that's a bare function call. You'll get an indirect field loaded function call, like the worst case retable scenario.
Yeah.
And okay, that's what you did. Same as you get out of C code. You loaded a pointer from memory and then you called it.
Yeah, well, usually if you're doing something that's crazily dynamic, it's not because you're looking for the best performance.
Right, exactly. You have some plan in mind. And that's probably what happens here. The implementation just will say, okay, I know it's function type. You can load it from a field and you can call it. And it's the shared
even in
field.
C++, if you get very vtable-y, you can land in load, jump, register, land.
Yes. Oh, C++, Java will definitely go there. C++, it used to be load once and jump, but if you're in a multi-inheritance hierarchy scenario, yeah, there may be multiple loads. Yeah, it could be. I have no idea. Yeah, not planning on doing any multiple inheritance thing. So that won't be an issue. And interfaces basically just keep adding methods or fields, keep adding fields.
So
demand the presence of fields.
I have another topic if we've beaten this.
Somebody's piling on negate, subtract. This is like Alan's question about typing.
Yes, I resurrected it with more complications.
Well, let me do Derek's, which I suspect will have less complications.
Hopefully. So what I've decided to investigate for my compiler is, basically the company has an LLVM compiler, LLVM based compiler already for a platform. It's pretty limited in a way, but it does generate code and they've written a fair bit. I was thinking that it would be nice if I could link in so that I could actually call my code from that. And I did a little bit of investigation looking at, how the .o files LLVM generates are structured and what the linker needs and stuff. And It seems feasible that I just need to generate relocations and maybe symbols. I'm not exactly sure what I need to generate. I'm wondering if I'm heading for a world of pain there, or if that's actually a reasonable thing to try and do.
I watched the Julia code emission on the jetted Julia platform using LLVM as the jet produce gruesome cross compilation unit calls because he didn't have a clue. So he only did a load jump register for every single cross compilation unit call. That was ugly. This might be a better question for Arthur, who's not here right now, I don't think.
Here right now, yeah.
But yeah, you have some tough calls. If you want to supplant LLVM, your company needs some runtime because that's not a short job. If you want to cross call with LLVM, there's performance issues. But if your performance is tied up in what goes in the PEs and what goes on the risk, whatever, the controlling guy is less important. Maybe you don't care about cross call performance, and Julia's technique was basically big old table somewhere, and they just indexed into the table and loaded a pointer out, called it.
Well, I was hoping that I could just like link and LLVM would see my code at generate O files the same as what LLVM generates, and LLVM wouldn't see a difference.
Maybe. I'm sorry, I shouldn't be answering. Somebody else who knows, who deals with LLVM on a regular basis. Where's York? Isn't he on?
I am.
He is, but he's quiet.
Yeah, aren't you cross calling with LLVM or calling LLVM?
No, I call Rust from my LLVM generated code, which that does bring challenges on its own. Well, I did also space out a little bit, so it's like a bit of a black hole until before this bit. Really, the main challenge of calling LLVM, what I ran into is that LLVM claims that their function calls that they follow the C API, but they do not.
So one thing I'm thinking I want to do is see if I can just get away with calling me from LLVM and never call LLVM from my code. So basically, I basically writing the inner loops type stuff myself, and all the sort of bookkeeping stuff. There's a sort of library that people have been using that's all sort of battle tested. That would be nice if I didn't have to rewrite that. So,
right, but when you say call LLVM from my code, do you mean that you're
not call LLVM, call LLVM generated code from my code? So they're basically
okay. So I'm going to be pretending. Generate as in you take LLVM IR from somebody else, compile that, or
let me back up,
or somebody has a shared library generated originally with some LLVM compiler, and you want to call that.
Yeah. So
okay,
we've got some C++ code that is compiled by LLVM, and it is fairly straightforward code that runs on our RISC controller on our chip. And so basically, that manages sort of communication, synchronization, a bunch of stuff. And then eventually it decides that it's loaded a frame of data and it wants to process it. At that point, I want that code that's written in C++, compiled by LLVM, to call code that I've written, not in LLVM with my compiled with my compiler. But I want to basically be able to give that to LLVM's linker and link that into the final executable, so that basically some compilation is done with Clang or however the LLVM compiles, and then I compile some stuff, and then I think it's LLM. I just lost the screen here. I think it's LLM does the linking and pull my code in, relocate it so it jumps directly to my code or whatever, and implement their calling convention.
Right. So a couple of things there. So as far as I understand, LLVM itself, like its IR and sort of how it generates code, is API-wise completely unstable. in the sense that even the IR in textual form is not a sort of
I
stable
wouldn't
thing.
generate any IR.
No, right. But so what you need to do is basically expose whatever code you want to call through some sort of C ABI. The usual approach to libraries, they want to bind against C++ libraries, so they have to make like C wrappers around it and then bind against that.
Yeah.
That works. That's what I'm doing. In my case, my library is a Rust library, small runtime library, and my code that I generate with LLVM will link against it and call it. For that, like this library just exposes basically functions using the C ABI, which in itself is stable. The problem you'll run into there is that even though LLVM's documentation state that the default calling convention is compatible with C, it is not. Specifically, the difference is that the way it handles passing structures as arguments is not compatible with C.
I remember
more
you
precisely,
talking about that.
Sorry?
I remember you talking about that. That sounded like a pain.
I might have mentioned it, yeah, somewhere on Discord. But basically, the problem I ran into like last week is I had a bunch of these runtime library functions that return a structure of two values, basically a tag and a value. In other words, a subtype. Because these functions needed to do error handling, and I didn't want to go with the pattern of returning an int as a status value and then writing to some sort of out parameter for various reasons. And that worked fine because these return structures were 16 bytes. Because two fields, both 8 bytes each. Then I had one function where in sort of initial prototype that I later ditched, I returned a structure that was 24 bytes, 3 fields of 8. And then basically all hell breaks loose. And you get these really weird errors where the call itself will succeed, but some of the arguments are overwritten with nonsensical values. In my case, I think like the first argument was like it was missing a bunch of bits, and then the second argument was 0. It was all messed up.
So not the return values were getting overwritten. So
right, but that's similar. I'll get to that in a second. And so after much Googling and trial and error, I found out, hey, it is because the structure that I'm returning is 24 bytes, not 16. If I make it 16, it works. Then I ran some tests where you pass structures as arguments, basically same thing. It completely messes up. And what I found there is that indeed LLVM doesn't actually use the C ABI when you use the CC calling convention. Specifically because it doesn't automatically handle passing and returning structures for you. You need to do that yourself. You need to figure out, oh, I am compiling for this target. They do it this way. And I found out by looking at the LLVM generated by Rust and by mine, and then you see, hey, if you use 16 versus 24 bytes, it changes. So that's the thing you need to take into account. Fortunately, on x86 64 and ARM64, it is exactly the same. They basically say if the structure is up to 16 bytes, we just pass it as registers. If it's greater, we essentially pass it through a pointer. So in the end, handling that was not that difficult. It's basically in my compiler, there's a check that says, oh, is the structure greater than 16 bytes? Do it this way. And then for that, LLVM does have there's a flag that you need to set on the argument or return type, which is sret, or structure return. It needs to be the first argument, I believe. It needs to be a pointer to some memory, basically your stack memory. So what my compiler basically says, if you pass a structure's argument, for example, it'll say, hey, is that structure less than 16 bytes? No, yes, we just, the argument is just a structure, the compiler does it. LLVM does it just fine. If it is greater than 16 bytes, we basically, with LLVM, do an alloca, where we allocate, let's say, 24 bytes on the stack. And then the first argument is a pointer to that chunk of memory. You have to set the sret flag on the first argument of the function definition. I believe you don't have to set it on the call. It seems to be redundant. And then I believe it will, well, then after the call, you have to like load that first argument into what your actual return slot, if you will, would be.
So, but if I'm doing a call with without passing structures back and forth, then it follows the CABI, and I can.
Yes, that. So basically, as long as you avoid structures by value as arguments or return types, you just call them. Like you don't need to do anything special in the LLVM IR.
Yeah. Okay.
And so in LLVM parlance, like you have to sort of define the signature somehow so that it knows what to call. You then do your build call, whatever LLVM called it, and off you go. So that, as long as there's a CABI outside of that, it's fairly straightforward, actually.
Okay.
If you want to optimize things, it gets a bit more tricky.
An infinite rabbit hole that if I try and go into, I'll never escape from. It's something that actually can be done.
Yeah, no. So calling like code is quite straightforward. It gets more tricky if you want to like do things like link time optimization, where let's say you have some static library written in whatever language, and it exposes a bunch of C functions.
Yeah,
this is what I originally wanted to do. I wanted my runtime library to be written, statically linked, and through link time optimization, optimize away the function calls.
Yeah.
And Rust, in theory, lets you do that, where you have to compile the Rust library like a specific way of like specific flags, and it will emit the necessary data. And then if you link things with, thin LTO, whatever the flag was, in theory, it works. In practice, it doesn't, because I got it working once on my laptop, like, I don't know, a couple of months ago. Then I updated Rust, it stopped working, and I've never gotten it to work on my desktop. So I gave up. I was like,
I thought that was the general development experience with LLVM. If you pull upstream, you start all over.
Well, so that I don't know. The thing here was this was a fairly new thing in Rust. I don't know if this is a thing with like C++, if they have support for this.
Right.
But basically, Rust added this option where if you pass a bunch of flags, they will emit some extra LLVM data. And if you then, in your own compiler, generate LLVM with the exact same version, like down to the minor version, and then you link it with the necessary link time optimization flags.
Yeah.
In theory, LLVM can optimize it as if it was one whole program. So you get rid of all those function calls.
So interesting. So you're saying that after I link, I give my code, I give the linker my compiled bytecode. LLVM is then going to compile and optimize that?
Yeah.
No, so the flow there was, let's say my example, I have my Rust library. I compile that to a static library, so a .a file on Linux. As part of that, I give it a bunch of extra flags so that Rust emits, I believe it just straight up emits LLVM bytecode in the archive, something like that, right?
Okay, yeah.
Then when you generate your LLVM code, you just, generate your object files as usual. Then when you link those object files to the library that we compiled earlier, that's where you need to specify like, hey, use link time optimization. And I don't remember if you could do like fat LTO or thin. I don't remember. But as part of that, however, you need to make sure that the linker is LLD, I believe, or basically Clang.
That's what I was thinking of using.
Because if you just use gold or something like that, they don't understand this. But basically, Andrew, is for the linking process, you need to use the LLVM toolchain, and then in theory, on paper, it would work, but I haven't gotten it to work reliably.
Okay.
And supposedly it is also.
I like the idea that there's like a second linker that if the one is doing something annoying, I can try the other one.
Yeah, so in the end, I just gave up on that. I was like, you know what?
Right.
My long-term plan is that my runtime library is
complicated language to deal with, though, and I'm dealing with something where my most complex type is a 32-bit int. And so, yeah, so like most of the stuff you're talking about, that I don't think it impacts me too much.
Yeah.
Okay.
I'm
All right.
surprised no one asked me what I did because I mixed TCC, Clang, my language, C, C++, and I do it on Linux on Mac.
Were you trying to
But
do
yeah,
link time optimizations?
well, I was trying to do cross inlining between languages.
Okay.
But yeah, there's some I had a fight with a linker and all that, but yeah, this might be too advanced, so yeah, I'll skip it.
Well, are we ready to change topics here?
Yeah, I think so. I'm
All right,
feeling a bit better about this a little bit.
a little bit. I want to pull up whatever. Alan, are you ready to do something here?
Yeah, okay. So let's see, is my cursor on the screen? Yes. Okay. So all right. So it's based on like this Elixir paper, which I put in the link section. The design principles of the Elixir type system. Okay, but like, all right. So the idea is like you have the standard library, right? Like that's at the top. So it just defines, your standard functions, right? So you have negation of an integer is the negative of the integer. I mean, it would probably be more complicated in practice, like you'd call it primop or something, but whatever. Well, it defines a negate function. And similarly, it also defines the subtract function, which is just adding the negative of the second argument. So then you write like your user library and in a different file, right? So that's what's new compared to what was on the Discord, was that you have different files by different people, and so this involves like separate compilation. Is that you're trying to figure out, how can the compiler handle all these files being compiled at different times in like so. And so the negate function is just like, the Boolean not. And then you also define an addition function. And this time addition, you're defining it, it's like the electronic engineering convention is that addition is Boolean OR. And so what you want is, so Jamie was like, well, why do you like dynamic types so much, Alan? All they do is cause problems. And I'm like, well, the answer is that if I have no types whatsoever, I can reuse definitions that look right, even if they have completely the wrong type. So like the subtract function, right, it's defined as like integers to integers. But because it just has this, add and negate definition, I can use that in my definition of Boolean operations as Boolean subtraction. And so I don't have to write any definition. So yeah. And so then like I showed examples of how to use it in file C. So you just import the two libraries, and then you can negate like a mixed list of like integers and Booleans, and you'll get, whatever result. And then similarly, you can subtract a Boolean from a Boolean, and you'll get a result. And so the question is like, how do you type this, right? Because it works fine if you don't have any types and you're just like in a dynamic language. But, so I don't know. So there's so the paper is like, you could use this, and that actually works for the list. So you could use this, and I think that also works for the list. But then like subtract is just like really hairy. It's like you can write so many different types that like I think the last one, the I don't care type is probably the best choice. So all right.
You can go two ways about it. One is we make the subtract an interface, and you have to define the subtract an abstract A to abstract A and implement it for all the types you want, and it will work. for the base types, of course. If you want for your type, you have to implement it. The other way around it is something like a higher interface, like a numeric, which is implemented for a range of types.
I have an
The
answer.
union here is questionable at best.
Oh yeah, that type for negate I think is incorrect. The second one is the correct one. You're one of either two functions, an int to an int or a bool to a bool.
You're doing something like the second one.
Yeah. So I have an answer for what AA would do here. Assuming you didn't type subtract and force the issue, then subtract is a function which takes a thing which requires a binary add and a thing which requires a unary negate. And then he just calls negate and then calls add. And that's whatever the types are, falls out from that. So you could do exactly this with subtract and have it do the right thing.
All right.
But I think the principal type of negate is
Yeah.
int to int and bool to bool, which in AA I would say I have an overload for the negate field. Your moral equivalent AA is you make an overload field for negate, and he has two functions, one int to int, one bool to bool, and he does overload resolution. And I'll infer the type of subtract as a thing, your third option there, a type A supporting add and a negate. And it won't, by the way, the third option you subtract is a type A supporting add and negate, means it's an A to an A to an A. It's not what it is. The A type has an add that takes the A and whatever is compatible with return of negate. So the B type, or the second thing in line, has to have a negate, and it returns something that's compatible with the add, the second argument for the add. And then the result is whatever the add returns. So they're not tied all to be A. They're in fact all three different types. And that's the most general type for subtract. I'll show you a different version of subtract here.
Okay.
So I have to go make it up in my head, but something here, A is a thing which has an operator add, which I can't type today, which is going to be typed from taking an A, it takes a B, it makes a C. And there's a B type involved, which has a negate. This has to take whatever is a functional type, it takes whatever comes out of the second argument, it has to return something that is compatible with the second argument to the add. So maybe I should call this a C here. We'll call this a D here. And then subtract is, it has A is a subtract, and he needs, yeah, whatever your subtract is, it's taking the A and it's a function takes an A and a B, and it produces a C because he takes an A and he's going to and a B, which he will then, oh no, he takes a D, and he'll run the negate, get you a B, that'll be compatible with the add of A and B, and that'll get you a C. So something like this. Typos abound, I'm sure, but there's some version like this. And all I did was I loosened up the binding of AAA to be ABC, because negate returns whatever, takes whatever, returns something that's compatible with the second argument to add, and then your end result is whatever add returns. That's sort of the, I think, is a more general type. Here is
So who is ever going to want or use that type besides you?
well, right, exactly. Let me pull up my current counterexample that I'm debugging. If I can go find it here. Because Windows kept choking on me here. So it's like more reboots than necessary. Okay. What is the type of factorial? So the type of factorial is a function which takes an x, returns me something, and the x supports less than or equals to an integer. It supports multiply. It supports subtract of an integer, and then multiply is to itself. And that works for ints to ints, and it works for floats to floats. And I get a type for fact, which is I take anything that supports the less than of 1, the minus of 1, the multiply of myself, which includes a matrix type. So I could do factorial of a matrix if I cared for such a thing. If I made up such a thing, it supported the right arguments. And that's the current type I'm inferring for this guy here. It's a function x, x, I think, and then where in fact x itself is typed as, I have a less than or equal to operator, less than or equal to operator, which has itself and a 1, and it returns me a bool, which for me is just int 1, and whatever other things here. Let me if you add your underscores to the operator names, it makes it harder to read, but you can tell it's an operator. And here's a subtract. Oh, geez, we've got new people showing up here. What the hell happened here? Okay, fine. Sorry. And the subtract, it's just a function from self and an int to what has to be here. I think it has to be the self type. So I probably should use X here, and I probably should use X here. I have to go look it up what I'm actually getting because I don't have that floating around. And then there's a multiply. Is an X, X, X. So it's something like this type. I don't have it exactly perfect, but it's something close to that. And then that type is satisfied by ints and by floats, but it's also satisfied by something that does any sort of reasonable algebra with multiplies and subtracts with ints and compares against ints. So that I think is what you're looking at, Alan, is what you could do with such a thing. Not claiming it's useful.
Well, I mean, I don't know. Like, I mean, if you don't have any types, you're just writing a dynamic language, right?
I'm statically typed, so I have types. I'm just inferring them all.
Right, and so you end up with these long, complicated types that nobody wants.
That's correct. No one wants to look at the type. I agree.
So, like, my question is, why not just go, use model checking instead? So they're like, you're saying, oh, well, we don't have types. We just have a model checker, and like it's this black box that tells you whether the type is correct.
Right, because I want to have a type that you could reason about, so you understand when it fails to type.
But it's already so long that you can't reason about it. I mean, we just saw you trying to figure out the types and saying, oh, I probably got this wrong.
Because there's so much detail in there. But I still think it's reasonable. It's reasonable. You can reason about it here. I can certainly.
Could you collect those requirements into types like numeric or arithmetic and comparable? Because I think you have multiple requirements here. You have arithmetic requirements like additive and subtractable, which would be satisfied by integer and floats. But you also have requirements like orderable or comparable, like less than an equal operator. And if you can combine those inferred types into those larger, say, type classes, then you would have also something easier to reason about, because then you can have a nice error message that you have supplied something which is not comparable to a function that requires comparable, for example.
Right.
What an interesting concept.
Right. So there's a difference here in that I can hand names out for these things as well, so that I can say this thing looks like it's intended to be comparable, and you didn't hand it to comparable, and hide the fact that I'm looking for the operator less than or equal to as your compare operation. I'm not saying that I should or shouldn't use the words comparable. The difference here is type classes, which add some names to things and give some restrictions on what you can and can't do, and add a funny requirement to how you invoke things. And here I'm like, but I can figure this out without type classes, but I could print the error message using something that looked like type classes if you're trying to diagnose what the hell failed.
Yes, and give the option to the user to optionally lock down the requirements, because maybe you only want your function to work on comparables or say integer
Oh,
or
yeah.
arithmetic types, but you don't want to say just ints.
Yeah, you could do that. So X here, just put a type on it. Comparable, and it has to be whatever other thing. It has to have a basic math, some numeric thing.
Yeah. But
Yeah.
I think that works, and that's a reasonable half point in the design, because you have some kind of type inference, but you also have a documentation for the interface that the function expects. I mean, I would say that even in Haskell, the general practice is that in top level functions, you do not rely on type inference alone, and you often leave some kind of type class in the signature so that the users of the library can reason about what the code expects. So
It could be. This is an experiment from my part. I know I can infer it. Now, is it usable because it gets too complicated too quick? I don't know. Maybe the answer is I shouldn't bother to infer. I should just require you top level functions have to have assignments. I used top level functions with assignment languages before, and the answer was half the time I wanted to type there, and half the time I didn't fucking care, and I wanted the damn thing to infer for me.
right, I think that's kind of convention. I mean, in Haskell, it's not required, and there's been a lot of experiments of not doing that, but I think over time, coding conventions have evolved so that people generally prefer to put some kind of annotations nowadays. It might vary, of course.
Yeah, well, that's where I'm sort of at here. I don't know what the right answer is for making this a usable typing system. I should be able to do all kinds of fun things, but does anyone care? Not yet, because I don't have it sorted out, but that's getting closer.
Well, I think you have to think about what a typing system does. Like fundamentally, a typing system is like a binary output, right? It either says yes, the program checks, or no, the program doesn't. Right?
I have a slightly different, but only slightly different view. I'm always going to type, but one of my types will be the error type so that I can get a hard guarantee of what the error looks like. I am requiring my errors to be canonical, and then I can pretty print them however I like.
Well, Alan is right about the type checking phase, not type inference phase.
I'm saying I will always type 100%. There is no failing method that fails to type. Everything types.
Okay, so you're saying it types, but you produce a list of like type errors where it did.
Yeah, one of the types is this is a type error. I'm not going to generate any code for you, but the point is there is a principal type which could include a type error, and the type error itself is a principal type, and therefore it has a canonical shape for a given kind of failure, and so you always get the same kind of failure for the same kind of typing error. As opposed to the scenario I worked on in a bunch of languages where if you had a typing error, somebody gave up in the typing process, they just quit, and you got an error that depended upon exactly at what point they gave up at. And they said, I screwed up here, and then your error messages were different for the same kind of error, and they exploded out in different ways according to wherever they were at the moment they decided they couldn't do it anymore. And here I just wanted to say, no, I can always get to the end. So your typing errors, if you have an error, it's always canonically the same, however you arrived at it. And that's just a slight variation on the I gave it up, because I'm not going to generate code for you. So that process is binary. You get code or you don't. But if you get an error, you get the same error, no matter which way you failed it.
Okay. See, like, so a model checker, what I get is like, I get a failing execution phase, right?
Yeah.
So I have like explicit values of every input, and it says if you do this, this, and this, then it fails.
Basically, my type errors are that. I give you the explicit complete path of you mixed up A, B's, and C's with A, B's, and F's, and they're not compatible, or however you want to look at it in that sense.
Right, but you get explicit values for each like input.
Yeah, it's not values, it is types. It's not values, but I'm not doing a partial execution and then failing. I'm doing fail at compile time. linear on
yeah,
the side of
I
your
mean,
program
honestly,
fail.
it's compile time too. It's not like, I mean, this is all compile time. Nothing's happening yet. You aren't running any of the program.
Okay.
You're
But
just
I claim
imagining.
I'll give you whatever you had as your types. If you had integers as types, you'll get the integers in your error message. If you have constants in your types, you'll get constants in the error message.
Yeah, but this is where you get into dependent types. Like what if, because like if you have values that your types talk about, then you need the values.
I don't, because I want to know that my typing system completes, in reasonable time always. Now but you can go do model checking and tell me how that works out for you. I have no idea.
Yeah.
I'm
Alright.
voting down for dependent types because I know I can get good performance out of this type checking.
Yeah, I mean, I guess that's the question is you have to ask people, do they prefer a simple system that works all the time, pretty much, but doesn't do what they want? Or
Right.
a complex system that sometimes does what they want, but other times just, churns and churns and never gives them anything.
Yeah, right. Well, time is part of the usability of these things. So I'm paying attention to how fast I can do this.
If you can consolidate it on the solution on a simpler type, it's always better, because if you produce a complex types constraint, the constraints can get unwieldy pretty quickly.
Right, and I'm not doing constraint-based typing on purpose because the error messages out of constraint-based systems got ugly. I am strictly doing unification-based, where I can get a pretty clear this and that do not unify. You're mixing an int and a float here. You're mixing a function and a struct. That doesn't work.
They're already very complex types. Like, I mean, you say they're simple, but like they are really complex in practice.
Yes, but the point at which they fail is going to be a simple, you've called less than, and there's no less than field in this guy. This guy doesn't implement the less than operator. That's the kind of error you're going to get.
The intricate here would lie the structural constraints, if you will, and the simplicity of types. That is the intricate play in this type system would be paramount. When the constraints can be substituted for a simple type, let's say integer, or when do the other way around. That's at least to me is an open question, because you're always generating constraints. You have to, not constraints, but structural constraints. It has to has this and this and this.
It has to have a particular shape. Yes.
Okay, the shape.
Yeah,
that's fine.
Structural. Yeah.
Yeah, and when another question is, do you want to go always structural, or do you also have do you want some place that you can substitute the structural shape for the simple type, or you always go structural?
I'm always structural, but if your structure matches the structure of like int, then I can substitute int in a pretty print.
That's okay. That's one way to go.
But like int has a structure as well. Int says I do subtract, multiply, divide, and a couple others. Fine, it has a structure.
Yeah.
If you look like an int in all ways, I'll just call you an int. And in fact, I track that pretty exactly on purpose for just this very thing.
Do you say if you look like an int, then I call you an int, or do you say if you look like nothing more, like the only thing you kind of look like is an int, then you call you...
No. If you look exactly like an int, then you are in fact an int, because that's the typing I'm doing. That's static typing.
Right.
So if you look exactly like an int, you're an int. And if you look kind of like an int, like factorial here is not actually taking ints. He takes a broader spectrum of things.
Yeah, but I guess what I mean is if the constraints develop to the point where the only type that you have in the system that's named that would fit is an int, even though maybe some parts of are missing, then would you still call it an int?
If the only thing it can be is an int, then it's an int. And we're done.
Right. So the only thing that it could be is an int, but maybe there's some pieces that int does that aren't asked for in the...
Yeah, that's still an int.
I view view this the structural constraints, if you will, for this are more powerful than the nominal types, because the structural things can fit much more types, and that would go int on double or anything that has these methods. So I view this operation as more general to substituting the structural for the nominal with its types. That's it's strictly
this is a more powerful typing system. Yes.
Mm-hmm. Because if you say I want to have these things, and you check, then this strictly types more program.
Right. So to the way Derek was putting it is, when I look at this thing, he behaves like an int, and if he's only using some of the int, that's fine. But when it comes to pretty printing the message, if the only thing he can be is an int, the pretty printer will pick up on that. But that's me doing a pretty print hack that just says, I can't be anything else, so I'll call you an int.
An interesting question would be to ask the type system, hey, which signatures does fit, which types does fit signatures, and it will spit it. It fits on int or string or metrics or however, which satisfy the structural properties you want in the
Right. So in the case of fact here, because he's called with 2 and 2.2, he's not an int or a float. He's this mixed type. If he's only called with a 2, he'll be declared an int. If he's exposed as an externally called function, he gets, again, the loose type, because somebody else can call him with a matrix, and he's fine.
But then again, I think we went over this. Does this let's say clone the in the call side, clone the function and instantiate the parameters for an int?
Right. The implementation guarantee here is that if there's a primitive being called on the arguments, I'm going to specialize for the primitive. And I haven't figured out how far I can push that one, but I think I can push it pretty far. So I would.
That's the monomorphization path. You want to eliminate all abstractions and substitute at the last minute, or substitute for the most precise type,
Right. Once I'm done with typing and decide that you're allowed to be typed, I can then go do more things based on performance and make sure I hit all my performance types. But they come as a second step. And in this case, in fact, I'll simply say, I have a function call with a 2. I'll put a 2 as an int. I'll make a fact that's typed as an int. Hit under the hood, I'll rename it secretly and give it a mangled name that makes it obviously the int version, and then one for the float version. And I'm done making versions because there's only 2, and those are the only 2 primitives here. And I'm done. Whereas the matrix version will sit with the generic, so there'll be a third could be a third factorial floating around, which is a generic one, which is going to do basically v calls for less than and multiply and subtract, and that'll be the one that matrix uses.
The conclusion, does fact a polymorphic?
I'm sorry, the conclusion.
So the conclusion, not the conclusion. The question is fact polymorphic? The definition?
It's based on the signature.
So
and I'll make a specialized float, but there'll be a general one that takes anything that matches that signature, and we'll return that thing back.
So fact is in fact.
Fact is polymorphic. Yes.
So if we stay on the structural side as much as we can, as long as the typing doesn't get too complex. So because here you will have one set of structural constraints, but if you combine the functions, you have to somehow unify their constraints and somehow produce a general structure that fit all of these call stack function, and that can get complicated.
Well, it's mostly working. That part's working. I get this type for fact fine. I'm missing the generic polymorphic version mixed with int, which I know what I did wrong and I know how to fix it, and so it'll show up. It's on its way. But I get basically this type for fact. What you're not seeing here is I actually allow overload resolution also, and that's in the signature I didn't show, but I could throw in the overloading question. It's a function. The type of fact is it takes this thing, it has a structural type, but the structures for less than and subtract, multiply. have one of these overloads and have some other overloads could be allowed, but I don't care what they are. So they're all ... So I'll give you the a more fuller type signature here, which is this, where I just have a tuple which has at least this overload in it, and probably some, well, possibly some other overloads. And I don't care what the other overloads are. And this all infers just fine right now. And actually, of course, you have ... here as well. Why did that print weirdly? Thank you. Let's give me some sort of umlauty thing. That's funny. Because you can have other fields on X. I don't care what they are. You know, matrix has a toString and has a read a file, write a file, has a matrix multiply as opposed to matrix int multiply, or whatever it's going to be. Yeah.
We've talked about this a few times.
Yeah, we've gone back and forth on it.
Yeah.
But you said something, you know, hey, this looks tough. No, it's actually about done.
Okay. The tough part to me is when you start combining much more and more functions that has only a structural body, and you start calling them, and does the type resolution would somehow to trip on it to infer the structure that pass all the call functions. For the one function, okay, that's mostly done. That's fine. The next step would be a function flag that call another function which itself has a structure inside with the more general, and that calls another structure, how that resolution would go.
Yeah, and that one's to be seen. I certainly can have one function call another. That's test cases, but I don't have like a large collection that sees that I blow up asymptotically or something weird like that.
Okay, that it might cause a problem. It might not.
Theory says it doesn't blow up because that's not what the theory says happens here. Practice, I haven't done it, so you know, we'll see when we get there. So far, I've been able to mostly keep the theory in line with the practice, so I think it's going to be good.
Okay, so from the theory side, from the theory side, when you call two functions that has a structure each inside them, you take the union of the structure. The resulting call is the union of the structure.
Yeah, totally. And that's a standard structural,
of course,
statically typed structure lambda calculus extension.
It might impose a problem. It might not. I don't know.
I mean, from the lambda calculus side point of view, the structure field names thing is completely well understood and well theory proven.
Okay.
And there's a bunch of implementations of people that do this kind of thing as a sort of standard extension. So that part by itself isn't difficult, or is well understood and well proven in a bunch of contexts. The overload is weird, and maybe it's not what you expect. And that turns into weird theory issues. The syntactic sugar, hey, bymass, for add, subtract, and multiply, divide, expounding out into the overloads is in fact sort of well understood. That one's not an issue. I think the only thing I'm really missing right now is getting the overload right, and then the automatic promotion of ints to a guy who has a struct with supports for add, subtract, multiply, divide, and whatever other things go off of ints. That one's also a little weird, and that I didn't quite get right the first pass, the second pass. I'll try again. Should we get it right third pass? And that kept changing how I wanted my primitives to look and how the syntactic sugar went. I went back and forth 3 different times and stuff like that. So mistakes were made. Well, I'll call it a research project.
Of course, that's process.
All right. Anything else? I'm going to probably call it before long.
Yeah, well, I had one other small thing that I just thinking about. It's not so much a question, but so related to making what I compile usable as a library, I have to I don't know, do something with exports, I guess. And I don't think this is too complicated, but the way that I've got my code right now is it looks for a main entry point and it compiles everything that the main entry point uses, and everything else gets eliminated. And so I guess I have to just define and like annotate my exports as exports, and then define them as like, and then compile them pretty simply, right? Like, I don't think there's anything too special there. I just need to preserve that arguments.
You can imagine the linker does dead code elimination by following names. Export adds a root name that doesn't get dead code eliminated.
Yeah. And then one of the things that one of the assumptions was that every module or every namespace can have global code. And so when I sort of build, so basically when I'm building the graph, I create a init module, like a init namespace function for each namespace. And then my main entry point first calls each of those, and then it calls the actual main that I coded. But I guess in this case, I should just create and export some sort of like init everything function that I just require the caller to call. Is that the sort of approach for this type of thing? Or
people do something similar. There's a couple ways to do it, but that's, yeah.
Yeah.
It's all magic. This is my do the things before main thing.
Yeah.
Java calls it CLinit, and it has once per class load before your first constructed object.
Oh yeah, okay. Yeah, so that's sort of similar idea.
It's distributed over time because classes are loaded. But the linker guys using AOT usually just say, yeah, run all the stuff before main.
Yeah. So I guess I should just see if the linker has something that as a standard.
It probably does.
Yeah, right. And if, yeah, so then I can integrate to that. Okay, that makes sense. Yeah, I think it's straightforward. I don't know. I'm going to do that in the next couple of weeks, I think.
Cool.
Yeah.
Whale, anyone else?
Oh, well, we had this long discussion about when programming languages are done. And I noticed someone posted like this, the signal and the noise, why so many predictions fail. So I was just wondering, when do you think AA will be done? You know, you have an estimate, you have a man months?
No. If you'd asked me a year ago, I said it'd been done now. So clearly my prior estimates were no good. So, you know, the next estimate has to be stretched out again. I'll run out of time and energy and money at some point, but not yet. I'm okay doing stuff.
Okay.
My estimates don't cover being inspired, and I get inspired often.
Well, I'm sorry, what didn't inspire?
My estimates doesn't cover inspiration.
Yes.
And I get inspired a lot.
Yes.
So the question is whether being inspired increases or decreases the amount of time and work you have left on the project.
I clearly got inspired to try a few things that I probably didn't need to. And so life got more complicated and it stretched things. Yes. That happened. Maybe more than once.
Yeah. My original estimate was that I was going to be done, I don't know, 8 months ago. But it didn't quite happen.
Yes.
I feel like I'm getting close now.
There you go. Yes, exactly. I think I'm getting close now.
Have you heard Guido van Rossum's discussions of how long Python took?
Oh, no.
Oh, yeah, let's hear.
So they made Python as an in-house programming language as part of a startup. And it took them essentially 2 whole years to get a version of Python that worked.
Right.
Which was enough time that the startup folded under the cost of developing the language that they were building in.
Right.
And when the startup folded, they said, hey, in lieu of severance, y'all just keep your laptops.
Yes. Okay.
So the team kept working on the language, but they had to throw away all the source code because it was proprietary and owned by some bank that was now caught up in a bankruptcy. So they decided they were going to start again with Python 2.
Oh, that's Python 2 versus 1?
Yeah, 1 was proprietary. So then they shipped
Wow.
Python 2.
I did not know.
And it was
this
like, by the
history.
time we got Python 2 to a good state was like 3 years.
Oh,
Then when they did Python 3, it took like a decade.
So I knew
So his
Python 3
conclusion
was
was the
forever.
more experience you have making a programming language, the more you are going to underestimate how long it takes you to make a programming language.
But I heard you say 5 years with a team working some amount of full time, at least for 2 of them. That's a lot.
Yeah,
of
the first 2
man
years were
hours.
basically full time, and then it got demoted to hobby projects as they all
Right.
went out and got jobs.
They had to get jobs. Yeah. Okay.
Was Python
But I think
1
one of the
ever-
reasons Python 2 is pretty good is that they implemented the entire language and then scrapped the whole thing and then used the
Yeah.
same team to implement the same language again.
Yeah.
And I think that's a real win if you can keep the same people through your build the whole thing, scrap it, build the whole thing again.
Yeah,
Sounds
I mean, I always found that my 3rd version is the best one.
Yeah, it's interesting that they didn't run into the second system syndrome, because what you often hear is that the second system is the worst.
Yes. Yes. I have. Well, if the team's experienced enough, they knew that already. I have been through second system syndrome myself. And so I've been very carefully watching what I do with AA and have been trimming interesting things out of it because, I got to get shit done or it's not going to ever happen. So,
Was the original Python publicly available?
well, it belonged to some failed banks, what I heard. Here, just go ask the interwebs.
Okay.
I'm sure
yeah.
somebody has a copy of Python 1 somewhere, but
Because I don't
What
remember-
I'd like to know is if anybody's currently licensing it.
Okay, here we go. I'm gonna throw it into the docs. Where's the link section? Somebody, early releases says, where do you come back here? My freaking window. Yes, 0.9.1. Andrew Dallek was clever and persistent enough to scrape Python 091 out of the usenet alt.sources archives and assemble a compressed tarball. It's mostly here as a historic relic. So he got it from things they published probably incorrectly on Usenet archives while they were discussing how to implement whatever. And the bank considered that, fair game or okay or whatever.
If
my guess is they
Python-
didn't consider it at all.
Yes. Yeah, yes. Good point. Yes.
If
Yeah.
Python 3 took a decade, I wonder what that's going to mean for the Mojo people.
I
think
you'd like to believe that this kind of discussion goes around, and so people are like eyeballing carefully here. 10 years, maybe we should trim our expectations.
I believe the most tricky part is the parts in the language that are not invented yet. They have to be research and
I
development.
think the really, really hard part is just making up the syntax. After that, everything's easy.
Yes,
Mm,
clearly.
the concepts
You
you're
have to
trying
spend a lot of time on
implement.
parsing automata. That's pretty much the entirety of language design.
I guess you could. I mean, you could spend time on that, but generally speaking, the hard part is picking the keywords.
Yes.
The
Where's
easiest
Simon?
is-
Oh, he was going to be on last week. We can talk to Simon about picking keywords. We're picking on you, Simon, about picking on keywords. Sorry.
I do think this group spends too little time on how to structure a good standard library,
Yes, I'll agree.
because I don't consider languages independently from their standard library. Like,
That was.
I
new
said that
in
once,
Java.
actually.
is Go a good language? Well, I think yes, but mostly because it's got a standard library that does the things I want. I can pick up Go and send a packet.
Yeah. Yes.
It's awfully nice when you can predict how the standard library functions work without necessarily having read them before.
Yeah.
I spend 99%
Clojure, I
of
find,
my
is better at
time.
that than most Lisps.
What's
I
that?
spend 99% of my development time working on API design for the standard library. That's what I do.
Yeah.
And it's one of the reasons why I stuck with Clojure, because I do like that aspect of it a lot.
There you go.
I
So
think there's-
Cameron, do you have a set of rules that you can boil it down to that's like, these are my handful of rules to guide standard library design? I know your first one is make a thing that fits together. You don't need to be other languages. You need to be your own language.
Yeah, that's in language design, certainly. Like the cohesiveness of the whole is far more important than any particular decision. But library design, I'm not sure if I can really boil it down. I mean, you know it when you see it. Like, you know, I can remember early C++ class libraries, and they just sucked balls. They're just horrible.
I think Josh Block raised the bar on standard libraries for the Java.
Well, a lot of the early libraries, even pre-Josh, were pretty good, coming from C++ land. And back then there was no STL. I mean, they pretended that there was, but there was nothing working until.
No, that was much later, yeah.
Yeah. So we had these commercial C++ libraries, and they were just designed by Satan. Like, and I'm sure you know what I'm talking about. Like, because
Hotspot just didn't use anyone else's libraries because they were too bad.
right, but you didn't really have that choice for a lot of things. Like,
Fine.
you know, I mean, Sun had a hefty number of engineers. You know, not every company can do that.
Right, but this was also an age that people referred to as the software crisis.
I'm sorry,
Like,
I missed that. When did this come from? What was the software crisis age?
It was businessmen complaining that most projects failed before ever getting to a minimum viable project.
Yes, that was.
And people were spending 5 years and millions of dollars and then scrapping the whole thing because it just was never going to work.
Millions of dollars. I haven't spent 5 years either, but it's been a while.
And I think the thing that solved that was mostly standard libraries that gave you basic functionality, that you weren't sitting there writing a red-black tree, you were writing your application.
Exactly, and I think standard libraries, like there's always a balance, and you'll never quite get it because someone's always going to want more control, and someone's always going to want less control, more done for more chewed for them. So you don't have to make everyone happy. But basically, you never want someone to look at it and be like, this doesn't, like, when I look at Java Crypto, for example, like, I'm like, what the fuck were they thinking? I know it was IBM, it wasn't Sun, but like, it's obscene. It's worse than obscene. It's like almost psychotic, like just the attack on the senses of the reader. And you know, there's just nothing right about those APIs at all. They're all 100% wrong. There's not, like, I've been through them a dozen times. Each time I have to learn it from scratch because there's nothing you can take away from it. But, you know, when you use a good library, a well-designed library, whether it was Josh's work on the collection stuff, which I do think in many ways was just beautifully done.
He raised the bar on that one. Yeah, definitely.
And given the time as well, like if we look at them today, yeah, we can spot all sorts of problems. But for fuck's sake, like that was 25 years ago. No one had ever seen anything. Well, no one outside of Smalltalk, which of course did everything first and perfect, had ever seen anything, you know, that nicely designed. And that's, you know, when I design an API, that's always what I'm after. I'm after that sense of, you know, when someone uses it, they may not like it at first, but they'll be like, oh, now it makes, like, if they understand the underlying topic, the underlying subject matter, the API should instantly make perfect sense. And if they don't understand the underlying topic matter, by the time they're done using the API, they should have a pretty good feel for what's actually happening under the covers.
Yeah.
And, you know, so those are kind of the approaches, but I can't, I'm not an author. Like, you know, Martin Fowler is a friend of mine. He's amazing how he can look at what other people do and then turn it into writing, even though he didn't do it himself. Like, so there's a beauty about being able to take concepts and explain them to others. I don't really have that.
Yeah, I mean, if you try to say what characteristics a good library has, whether it's a standard library or just any other library, like, wouldn't it be some things like doesn't do unexpected things, like no unexpected global state mutations when you're using it, you know,
Hey, no picking on Levo.
Of the similar type or in a similar order and all the different call set, like all the different functions.
Kind of implies, and that I think that's a important design for C. You say no state changes, no mutation. That means you should never implicitly allocate memory, which means you should always take buffers in C. At least I think that's an important design principle. Never call malloc inside any of your functions. Because if you do, and the user is using their own malloc, you just completely screwed them up and they can never use your library, no matter what.
Yep.
It's an unfixable problem.
Yeah, there's never would you, yes, never call malloc in C. The end.
Hey, guess what? You don't call
This
malloc
is
in
not bad,
Golden.
this is not about generalization.
That's
Right,
why
for
I don't
example,
say
Java's
the
very
C++
different because it's got the
library
GC
called
and you
malloc.
assume people are going to lean on it.
And I think
Right.
that's also why you have this stratification in Java. There is this small group of programmers who use Java for HFT, high frequency trading, small relative to all Java programmers, and now you screwed them up because they can never use any of those Java libraries. They have to write everything from the scratch in C-style Java.
But
we already
the-
know,
Having
but
worked on a couple dozen HFT systems, you would be quite surprised that they do not limit themselves based on what you think they would limit themselves by. They're more than happy to call new in almost every single. In fact, I only saw one or two over 15 years that avoided allocations, and one of those was the kind of hand rolled. That wasn't even an HFT system. That was actually a stock market implementation in Java, I think in Sweden, or something. And the other was
we need Martin Thompson here. Speaking of implementing exchanges.
Yeah, exactly.
All right,
So,
all right.
but very few of them actually tried to avoid. I mean, they obviously weren't silly about creating billions of objects, but the whole idea was they didn't have to be zero latency for every trade. They just had to be zero latency for 99% of them.
I kind of wanted
Right.
to finish my list here, but it sounds like Cliff really wants to go get some lunch.
Well, you know.
Well, I think I just have one more thing, which is functions should really just do one thing. Like, you know, if you have a function or a method, especially if it's in a library, like don't try and do a bunch of different things all in one function call. Split it up.
Can I play a devil's advocate for that? I think the ending pattern one can arrive is that then you have a required sequence of function calls. And that I think is an anti-pattern when you have always a function called pre-initialization, initialization, do the work, and tear down. And if you forget any of those calls, it's wrong and it's not going to tell you. So in a way, you may sometimes need functions that do more.
Yeah, well, you have to do the minimum. You have to do like the minimum necessary, not less.
Now to play the devil's advocate, maybe you wanted to batch this, and then you actually didn't want this initialization to be done on every single operation. You wanted to be done once and upfront.
It's in the eye of the beholder.
So we'll
Yeah.
just leave the library as simple as possible, but no simpler.
Yes.
So Matt
That's-
arguing with himself just explained the entire design for C++ iterators, just to be clear.
My biggest peeve in coding is when a person writes a function, they split it up into 3, and each of those functions, they don't work by themselves. You have to call them with each other. So there's 3 separate functions I have to jump into because somebody thought they should write short functions. I absolutely dislike when people say you have to make your functions short, because I get problems like that. It's so annoying to understand when you're trying to debug a problem.
Yeah, I think short is a bad criterion.
So bad. It's ridiculously bad.
Yeah.
But again, the splitting of the functions into pieces, I mean, sometimes it really makes a lot of sense. Sometimes it really makes no sense at all. I think this is hard.
If they can,
My goal
if
is
they
to
de-
minimize the surface area around a function of what interacts
they-
with what, but.
yeah,
That's-
if a function depends on something else being called after it, just make it one function. That's the thing that bothers me the most.
Again, think about batching. I mean, what if the 3-step process is the, again, initialization, do the work, and the teardown? and you want to call this in a for loop for 1 billion of operations, then you probably don't want to do the initialization and teardown without necessity. Maybe one is, for example, maybe initialization is open database connection. Do the work is do something with the database, and teardown is close the database connection. You probably wouldn't want to reopen the database connection, closing this 1 billion times in a loop.
I half agree.
isn't-
It's not like you have to call it initialization A or B after initialization starts. That's the specific thing I'm bothering about. I'm annoyed about is if you have to call something afterwards.
All right. I think this is a great conversation to have next week.
Okay, we'll solve API design next week.
The good conversations always comes last.
Yes, and we could run a long time with this good conversation indefinitely, but also I have to deal with the giant ass recording and stuff. So going to call it quits. I'm happy to, bring it up next week. Anyone can welcome to pile in on it. It's all good. All right. Until next
See
time.
y'all.
Bye.
Bye.